Welcome to part 2 of the Evervolt Certified Installer Program. Today we're going to talk about designing Evervolt systems. This is a detailed look at a typical Evervolt AC coupled wiring diagram. You can see that on the Evervolt inverter there are a few major connections. You have your battery connection that goes directly to your battery cabinet. You have your grid connection, and that's going to go to a 40 amp breaker on your main service panel. And then you have your load connection, which is going to be tied into the essential loads panel that the customer chooses which circuits from their house they are going to back up. One of the main advantages of an AC coupled system is that it's simple because it's independent of the PV system that's currently existing. It's compatible, therefore, with all of the leading PV inverters on the market today. We can do frequency control with some of the newer PV inverters on the market, which we'll talk about momentarily. We can integrate with a generator. So it is an additional accessory, one of the few that is available for Evervolt. But if a customer already has a backup generator or they need additional power, Evervolt can integrate with that generator. And here with the AC coupled system, you get a full Panasonic system when choosing our Panasonic ACM modules, along with an Evervolt energy storage system. Here's a more basic view of an AC coupled Evervolt system. The green arrows are indicating certain directional flows of power. So you have your PV array, in this case with N-phase microinverters built into the back, that is sending power to your central loads panel, which is then in turn sending power to the backed up loads panel, as well as to charge batteries, or vice versa if the batteries are feeding the backed up loads panel as well. And this is when you have your grid present. Now when the grid goes down, these power flows are still happening, and the challenge becomes if the PV power from that array is greater than what is needed by either the batteries or the backed up loads, that power has nowhere to go, so the system has to trip. So what happens in a situation with an AC coupled Evervolt system and a PV array when the grid goes down? The first method is a very simple method where it's called AC frequency and trip. So when the grid goes down, the Evervolt inverter will shift its frequency to 62.5 Hz, which the PV inverter will see this and shut itself down. The PV inverters per IEEE 1547 will wait 5 minutes to turn on again. If there's nowhere for the PV's power to go, as far as the batteries or the loads go on the house, then the PV inverter will remain off. The second way we can handle PV power is with a kilowatt limit set on the PV inverter itself. So in this case, when the grid goes down, the same order of operations will happen as an AC frequency trip, where the Evervolt system will shift its frequency. Now this will cause the PV inverter to trip, and it will wait 5 minutes to turn on again and look for that grid frequency. If the power is still too much from the PV inverter and there's nowhere for that power to go into the loads or into the batteries, then what can be done is a manual setting on many PV inverters will allow you to limit that power output. For example, if you have a 6 kilowatt PV inverter, you could manually set a limit for during a grid outage, so that inverter will only be able to output 4 kilowatts if you want to match your battery load or your house loads. The final way and the preferred method is to do AC coupled PV system with frequency watt functionality. So the bottom line is you're going to be using Evervolt to control your PV inverter and throttle the power from that PV inverter so as best to match what is required and what is needed by the home loads and the batteries at that time. So in the PV inverter, there are settings that you can make to set what the ramp down rate is. And essentially what this will do is the Evervolt inverter will shift its frequency, as you can see here, to curtail that power output from that PV inverter to align with what is needed in the house or the battery at that time. This is a wiring diagram for a typical N-phase system with Evervolt. You can see the N-phase IQ combiner is tied into the backed up loads panel. Similarly with Evervolt tied into the backed up loads panel, and then you can see Evervolt going into the main service panel. Similarly with SolarEdge, you can see that both the Evervolt inverter and the SolarEdge inverter would be tied into that essential loads panel. These are the basic guidelines for sizing a PV array with an Evervolt AC coupled system. The general guideline is to size the PV array so that it is equal to or less than the maximum AC power of the PV array. This would minimize the chance that the system would trip during a grid outage. As you can see in the Evervolt standard model, the battery continuous output power is 4.4 kilowatts. If you're looking at the IQ7X, which is what is included on our Panasonic AC modules, each of those are rated at 320 watts peak power. So by doing the math of the 4,400 watts divided by the 320 watts, you'll see that we come out with 13.75 IQ7X microinverters, rounding down to give a total number of Panasonic AC micro modules of 13. Similarly with the Plus system, the math using the 5,500 watts divided by the 320 watts of the IQ7X, we come out to a total recommended system size of 17 Panasonic AC modules. Now again, this would be the number of AC modules that would be tied into the essential loads panel. If you do need a PV array that is larger than this, you could simply take the remainder of the Panasonic AC modules or the IQ7 series microinverters and tie them into the main service panel. There are some sizing limitations on the PV array that's coupled to an Evervolt AC coupled system. As you can see here for Evervolt standard, without frequency control, as mentioned, you can achieve up to 4.4 kilowatts of AC PV. With frequency control, specifically with N phase, you can achieve up to a 6.5 AC kilowatt PV array. And with other PV inverters or string inverters, that number drops down a little bit to 6 kilowatts. And the same numbers apply for Evervolt Plus, 6.5 kilowatts for N phase, and 6 kilowatts for other inverters. This is a look at a DC coupled Evervolt system. So you'll see it's very similar to the AC coupled, with the main distinction being that the PV array is going to be tied directly into your Evervolt inverter in PV array input. Everything else is essentially the same on the system. Main advantages of DC coupled is the simplicity in that you only have a single inverter that is acting as the brains for the entire system, including the PV array. A DC coupled system is slightly more efficient because you have fewer losses since you're not converting the PV array from DC to AC back to DC into the battery. The DC coupled system is going to be a slightly lower cost system in most cases because, again, you're having a single inverter instead of two inverters installed with that customer. We have generator integration similarly to the AC coupled. And for a full Panasonic system with our DC coupled, you can use our Panasonic HIT modules with the Evervolt system. This is a simplified wiring diagram for a system where we are stacking 3 Evervolt systems together. You can see that the inverters each are tied into a 600 amp combiner box, which then goes to the battery cabinets. The reason that the 600 amp combiner box is there is because all of these batteries are installed in parallel, so we want to ensure that they're charging and discharging at the same levels simultaneously. The remaining loads output will be going to your automatic transfer switch to achieve the whole home backup, which can include a generator integration. And you'll see that there is a 48 volt charger shown on this particular wiring diagram. This is not required, but this is only used in this case because the generator is being used to charge the batteries. So in the case of the grid being down and all of the batteries being depleted, the customer can manually turn on this generator to recharge those batteries. The other way to install a generator, which we'll cover a little bit later, is simply to tie it into the backed up loads panel and use it to power additional loads. You'll see that the number of Evervolt systems is shown on the right with the various specs accordingly. So for 2 systems, we'll have 9 kilowatts of continuous output power, and 13 for 3 systems. For 2 systems, the continuous current will be 46, and for 3 it will be 69. And for 2 systems, the maximum number of energy capacity that you can have is 68 kilowatt hours, whereas for 3 you can scale all the way up to 103 kilowatt hours. As mentioned, Evervolt can be used with an external backup generator. There are 2 ways to do this. The first is you can have the generator provide additional power to the essential loads panel when needed. This can be done via generator auto start functionality. The second way is to have the generator charge the batteries when they are depleted. This is a manual operation that the homeowner will need to do during times of grid outage. There are a few basic tenets to abide on that generator. The first is it has to have clean 120/240 split phase power at 60 Hz. Single phase and 3-phase generators are not compatible at this time. The generator should be at least 6.25 kilowatts, most likely greater, to provide the additional power needed for the backed up loads. Continuing with the theme of simplicity, there are only a few additional parts available for Evervolt. When you order an Evervolt system, you will order either an Evervolt AC or DC coupled model, and of those models, it will either be the standard or the plus configuration. Outside of that, you have these additional options. You can have CTs, either 100 amp or 300 amp options available. The meter is built into the Evervolt inverter. A cell modem, which is coming in the second quarter of 2020. If you would like to currently use a cell modem, you can simply use one from your local phone service provider that has an Ethernet port available. And then finally, the generator integration kit, as we mentioned previously. And that concludes the design portion of our Evervolt Certified Installer program. For any additional questions, or if you're looking for additional resources, please refer to our website, or you can reach out to your Panasonic sales representative.